Hey everyone, my name is Akshay, as Robert introduced me. I'm a product manager here on GKE, and most of our roadmap is to focus on how to make the quality of life of data applications run better. So let's get started. So for the agenda, it's going to be really simple. It's going to be around why do customers even run data applications on Kubernetes in terms of the positioning and the value propositions. You have great platforms like Alinity and SaaS applications. You should absolutely use them. But Kubernetes has its space of if you want to manage your own infrastructure. So you'll learn a little bit about that. And you'll also learn about how Kubernetes itself is evolving to make these applications, such as data applications, run better. So this talk is more, it's not at the application level, and this is why this talk is flagged at the infra level. So this is more around the underlying infra that powers this application. So I just want to put that out there. If you're more on the app level, this may or may not interest you because this is quite low in the stack. So what are we seeing in terms of the trends on data on Kubernetes? We do see there's a nice community called the Data on Kubernetes community. It's adjacent to the CNCF, and they ran a survey and say how many customers on Kubernetes run data and stateful applications, and there's like 70% of customers run them. So it's a sizable population. And what you see the diff between the 2021 Data on Kubernetes report and the 2022 Data on Kubernetes report is you see a journey our customers went through of kicking the tires in 2021. And in 2022, they actually saw some sort of productivity gains and more like production use cases. And a lot of them said they had at least a twofold gains in productivity by running stateful apps on or data apps on Kubernetes. And a lot of these were like databases and AI/ML were some of their top trending apps, which was where they kind of really leveraged some of their productivity gains. And even if you look at the more global all-up CNCF survey, I think databases, messaging, big data, all of this is seeing tremendous growth. So Kubernetes is inherently getting ready for this whole data wave and then also the AI/ML and associated data wave. If you look at our metrics, this is our public stat. We took a look at all GKE clusters running data applications. And it's growing exponentially. It's doubling every year, all the way back to 2018. So it's definitely a trend we see not only in the industry, but also if you look at our own metrics, those numbers do make sense directionally. Some of the apps built on top of us. So a lot of stateful apps are built on Kubernetes. So this is just giving you some names, just to give you a sense that this is a real thing. And what we're seeing is some of the more modern vector communities and feature stores, which is the more hipster databases that are associated with AI/ML. They are now leading with Kubernetes. It wasn't so for traditional databases like Postgres and Kafka. It was more around VMs. But the newer databases are just directly leading with Kubernetes and a container-based deployment because of all the reasons you'll see later on. And here's some production examples. I won't get into this in detail, but this is a multi-AZ Kafka architecture by Etsy on GKE and how they were really able to lower their costs. And it was quite a big deployment with over a petabyte of data. So now, why do customers run stateful apps, and what's the different operating model of stateful and data apps on GKE? We see a lot of customers run apps by themselves, and this is the DIY mode. This operated in this way. Let's say you take a container image of Redis or Druid or MariaDB, and you just run it yourself as a container. So you get a lot of control operating this way. You have to build your backup plan. You have to build your HA solution. So it is self-managed. You get a lot of control, but also a lot of control comes a lot of responsibility. So a lot of customers say, hey, I don't want to do this myself. I want some help. I want some help with experts of these stateful apps. let's say it's Alinity. And for that, you want, or Elastic, that's also a very popular one we see. So for that, customers use a Kubernetes operator pattern. So operator patterns, basically you run your container image, but you also have a Kubernetes operator to kind of orchestrate and deploy these container images. And these operators are often software provided by either Elastic or any one of the application developers themselves. And there are also OSS communities here. So you get a lot more help rather than the DIY mode in terms of it's kind of partially managed, but you do run on your own Kubernetes infrastructure, so you can control costs you have, or you can run it on-prem. So there's a lot of flexibility you get from that. And finally, the third operating model we see is customers run SaaS applications. I mean, this is the data wave and has led to a lot of SaaS innovations. And operated in this way, customers running SaaS don't care much about Kubernetes. They just have an endpoint and then it just works. And of course, this is a super popular pattern as well, because data SaaS applications are getting so mature that not many want to actually manage the underlying infrastructure unless you're a more specialized customer. Then why would anyone actually choose GKE? Because these SaaSes are so great, or any Kubernetes based deployment. I think the first one we see is essentially Kubernetes has a lot of built-in orchestration. It's also multi-cloud, so it gives you a lot of primitives to orchestrate deployments across clouds. And you have, even within a cloud, you have a lot of benefits like CI/CD, stateful. So it's more managed than just running and orchestrating VMs yourself. So it gives you that out-of-the-box bang for your buck. We also see customers have organizational gravity. So as Kubernetes kind of becomes an operating pattern in a large organization, it's like the sun that bends space-time. So all the other applications fall into its orbit. And stateful and data apps is one of those apps which kind of get attracted into the realm of the Kubernetes operating pattern. So it gives the infra team consistent operational practices for the infra for both stateless and stateful and data apps. And then, as you can see, our ecosystem on the data on Kubernetes, as you saw, like some of the stats I shared before, the ecosystem is really developing fast. So a lot of customers do benefit from either the OSS operators or the first-party operators to really benefit from running on stateful. We also see SaaS customers themselves run on top of Kubernetes. Let's say your Alinity or MariaDB or even Databricks, for example, they run on GKE as well. You wanna essentially have a deployment that is multi-cloud, because you have customers in AWS, you have customers in Azure, you have customers in GCP. So you want to be able to run multi-cloud infrastructure. And also multi-cloud is important when you also have customers running some of their applications on-prem. So it's a good way to kind of go to your customers on-prem and say, hey, here's a Kubernetes operator, and if you're coming to the cloud, use our SaaS. So it's like a funnel built by many of our SaaS customers. And what is important with Kubernetes is because it's open source, and the patterns of operating infrastructure is similar from on-prem to all the three cloud providers or the three major cloud providers. You get that consistency. The second thing is, if you're building a SaaS today, as you'd want to leverage more modern compute orchestration. Like, yes, you have VMs, and there's nothing wrong with VMs. You can run VMs, but you have to build a lot of the orchestration on top of it. The CI/CD best practices, your deployment best practices. So you want your cost savings. So all of that you want out of the box. And that's what Kubernetes and managed Kubernetes solutions gives you. It gives you like a more modern way to deploy and run compute. So that's also exciting for our customers. And finally, there is some nuance of a lot of the SaaS customers run Kubernetes. So speaking the same language and vocabulary helps build some empathy. So it's interesting to see that being a softer reason, but one of the reasons. What about, so I want to say, as Kubernetes is great, But definitely, I wanted to make sure I end the positioning part of this presentation with this is definitely consider managed services and SaaS services first for your use case if you want to run a stateful app. Because there's a lot of it which is completely managed for you. You don't have to do any of it yourself. But if you want to manage it, like for example, if you want to build your own DIY, you have some expertise in house, you want to build your own internal SaaS for your users, then of course Kubernetes is getting really, really powerful, and it's going to get even more powerful as you'll see how it's evolving in the subsequent part of this presentation. So we took a look at, why Kubernetes for data and the trends of data and Kubernetes and the kind of customers and use cases. Now, this time, let's take a look at how Kubernetes itself is evolving based on customer feedback and some features. I'll quickly go through some features just to give you a sense of, where the puck is headed. A lot of customers who run data applications, we took a lot of their feedback, and their feedback came to three big themes. The first one is safety controls. You're running data, you want protection over having backup, you want to deploy your application safely such that there's no loss of data or your disks have high durability. So there's a lot of requirements around safety controls. Which is unique for data apps and not true for stateless apps, which is more, fire and forget and churn container kind of mindset. So that's one big theme which customers ask for features around. The second one is stateful applications can be a handful to manage. There are a lot of moving parts, like there's the compute part, there's the networking part. Now you add the storage and the data part with it. So there's more moving parts, and with more moving parts come a lot of interaction between those moving parts. So customers ask for, hey, can I have something more built into Kubernetes, a more stateful aware features? So that's a common feature set customers ask for. And finally, storage. I think what's interesting to see is storage has been vastly a commodity for a long period of time. But you'll see now there's been, with at least the AIML and the data and keeping the GPU hungry, customers want like better storage, which is more cloud native and easier to use, and a lot more high throughput, low latency. So even storage is evolving, as you'll see later on with some of our object and file kind of overlap intersections. You'd see it's an interesting space as well. And customers want all of these storage types fulfilled through a very container native CSI, container native storage kind of interface. And that's where you'll see some of the features as well. There's a very high level stack. I mean, it's a little bit of a representation of what we have underneath the hood. We have, we have one layer just for the safety controls and the orchestration. So stuff like backups, upgrades, built-in HA, more features of safety controls where upstreaming to Kubernetes OSS. So that's one layer. And then the second layer is, of course, like the storage integrations. We're always adding more storage integrations and adding that in a way where it's easy to use through Kubernetes. So you can use the Kubernetes YAML infrastructure as a code way to deploy your storage as well. Take a look at a little bit of the stateful management layer at first. The first layer, I think the first one is backup. Backup for GKE is a feature we launched. You can also use open source backup solutions like Volero. And this is something which was very popular asked by stateful customers. As you can imagine, they want to have fine-grained, scheduled backup policies. And that's possible within Kubernetes directly. You don't have to use an additional interface. So the advantage here is you can use your IAM policies on how you separate your namespaces. Let's say you have a Kubernetes cluster with a namespace for stateless apps and a namespace for stateful and data apps. You can just say, hey, back up my namespace of stateful or my data apps, and it'll just work. So it works well within the Kubernetes interface. That's what I meant by the features are well integrated with Kubernetes. It's essentially capabilities like this. Apart from backups, we also have a lot of features for upgrades. I think one of the big common, if you look at some of the more managed cloud providers, data applications like Cloud SQL and RDS, they talk about blue-green deployments. So what we did with GKE and Kubernetes is also like offer blue-green deployments as a built-in primitive. So you can essentially have a out-of-the-box blue-green experience without having to orchestrate deployment pools and route traffics. And we have a lot of other benefits like maintenance windows, which is very popular with data applications because you don't want to upgrade your data apps when you're having your peak sales event. It's just not best practice. And a bunch of goodness like Kubernetes pod disruption budgets, all of the best practices out there. It's something you get with Kubernetes. I'm not going to go through this, but we do also walk the talk there. I just skipped through it, but we actually live upgraded a Redis deployment, which is cool. And we showed that, how it's super easy and streamlined and you don't have to do anything yourself. We even published a bunch of content, which is all public documentation, works on GKE and Kubernetes in general. So you can check all of this out later. The final few parts of the whole orchestration layer is also HA controller. We launched an out-of-the-box capability with HA, and we're working with the upstream Kubernetes as well to figure out how to make HA more built-in Kubernetes primitive. And in this particular feature, we used regional storage to kind of give you like a storage replication without having your app to do a lot of replication. I think one of the key features or key value props this gives customers, it saves them a lot of cross-zone networking costs. Because as you can imagine, stateful apps do share a lot of data amongst each other to reach quorum or to be consistent with each other. So this is a feature which we launched as well. But just to give you the kind of examples on how Kubernetes is evolving at the orchestration layer for stateful and data apps. And yeah, there's of course like a lot of OSS capabilities, like out of the box Google managed Prometheus, or if you want to run Prometheus yourself, you can as well. You get all of these metrics out of the box, and we are constantly working with the SIG storage community to make Kubernetes better. So we took a look at the first layer, which is the stateful orchestration layer. I just want to briefly touch upon the next layer, which is the deeper storage integrations and what that means for you when you're operating stateful apps on Kubernetes. At a very high level, you have a lot of choice. So you have persistent disks, which is more typically block storage. GCP launched a new version of persistent disks, like a new evolution of it called HyperDisk, which has a lot more benefits of decoupled architecture. But PD and HyperDisk are a traditional block storage. So this is used by customers who know about storage, who have some on-prem experience. Then you have cloud file store. File store is a fully managed NFS. It's actually getting quite popular with AI/ML and data because customers like that it's fully decoupled from VMs. And it's just like an endpoint where you can access your data. So it's regional and it's getting super popular. It's traditionally for content management system, but it's interesting to see it's also getting more pull from the data apps and the AI/ML apps. Local SSDs, this is essentially ephemeral storage, super popular with AI/ML because it has NVMe high-perf storage locally. And what you'll see is a lot of customers running AI/ML and data apps care about the utilization of their compute resources, especially if you're running GPUs. And they don't want data to be the bottleneck. So they do have provision local SSDs as a high-performance cache in their nodes. GCS Fuse. This is some of our, the first three are more traditional, block, file, and local storage. It's something you have on-prem as well. But the other two is more cloud native, which is more newer. One is, of course, GCS Fuse, which is file semantics in front of GCS. You may ask why the hell you'd need something like that, because we do see a lot of customers use file semantics for portability from on-prem to the cloud. And for simplicity for the data scientists, because they don't want the data scientists to say, hey, import the AWS SDK, import the GCP SDK, import the Azure SDK, use all of these different APIs. They want code that's portable, and file semantics is really popular now. And we see that you'll see some of the use cases later as well with this. And finally, the more newest one is Parallel Store. A parallel store is a high-performant, fully managed parallel file system. It's built on technology called Intel Taos. It's open source, the technology, but the product itself is fully managed. And what you see is parallel file systems had a background in HPC and on-prem. But you'll see in the cloud, it's very AI/ML focused. There are some HPC use cases, but a lot of AI/ML customers have taken to it because of how good it is to manage data. Just a little bit of overview on all of these. Just a little bit of a double click. I won't go too deep because we don't have too much time today. But as I said, starting with hyperdisk and block storage, it's more for, it's the next generation of block storage. It's completely decoupled. There's a lot of choices for you. You can run a bunch of different applications, from data apps to like databases. And you have choices across price performance tiers. And the nice thing about hyperdisk is the architecture is decoupled from VM. So you get a lot of independent performance tuning, which a lot of storage administrators on-prem really appreciate. It's something they're used to on-prem. And this is something which enables you to have that decoupling in the cloud as well. So that's one which we have, which we launched recently. The other is file store. As I said, file store, unlike persistent disk, is like a decoupled, managed regional endpoint. It's simpler to use, as in you don't need to have much storage administrative experience, and because it's a fully managed NFS endpoint. And the thing about file store, which is unique, it's both multi-reader and multi-writer. There's some SaaS applications, like a good example is like, let's say, Google Docs, where there are multiple readers and writers simultaneously, or SaaS applications like Atlassian, where you're all modifying a Jira ticket. So that's where cloud file store becomes really popular. And because of its simplicity, it's also seeing some AI/ML applicability as well. This is just some relative comparison between the two. And this is a specific use case of a customer who use cloud file store. This is a Google itself, Google chip design. They use cloud file store, and they used it for development of our chips, including TPUs. So it's interesting to see that the last two gens of TPUs is built on GKE and file store. Just for how easy they were able to run simulations on using a file store as a data store. We took a look at block file. Finally, local SSDs. I mean, this is super simple. You can take a look at it. It's just local NVMe storage, which just comes with your node. And I think the keyword here is 2.4 million read IOPS and 1 million write IOPS per node. So it's high performance. And that's why customers like it, because they use it a lot for their AI/ML applications. And this is what some of the API surface looks at. We took a look at block file and local storage. Now let's take a look at the more modern, fun stuff. There's a lot of more. From here, Kubernetes is just supporting these primitives well using cloud-native storage offerings. What you'll see in the next two is there's a lot more innovation here. There's newer stuff happening in GCP, in AWS as well, with cloud file, basically object store and parallel file systems. Specifically, as it comes to object store, we launched GCS, which is Google Cloud Storage, which is Google's GCP's object storage. We launched a CSI driver for a Fuse interface. And what it is it's super simple and easy to use. The nice thing about building it into Kubernetes is we have IAM based auth. to access your GCP buckets, and that comes through as workload identity. What I mean by all of this is, let's say you have a data science team A who can only access certain buckets, and data science team B who wants to access only certain buckets. You can set granular permissions for each of these data science teams, and you can group them by namespaces in a Kubernetes cluster, and automatically those permissions flow through. So you can multi-tenant your underlying infrastructure in Kubernetes and gain that cost efficiency, and yet get control over who can actually access your data. So that's the powerful experience you can get with Kubernetes and some of these storage interfaces. And of course, this is the reason why we built the CSI is, it's a fuse-based interface. So if you have file semantics, you get a lot of portability. And that's where we see customers use this. This is how it looks at a conceptual level. You have customers use file semantics is supported in all popular frameworks, TensorFlow, PyTorch, Horoword, and you just have to access your data like a local file. But it's actually the data sits in object storage. And just to tell you that how this is quite a popular trend, recently at reInvent, S3 also launched Mount Point, which gives you file semantics in front of S3. It was launched like 6 or 7 months after we launched this. So it is something which you'll see Kubernetes evolve and kind of see this pattern evolving as well. Here's an example. We have a customer called CodeWave, and they were doing Gen AI. They have this app where you can create your avatar. You can upload your image, and it'll create many different avatars using generative AI. It's a super fun app. Then this is their architecture. They used GCS Fuse to simplify loading and accessing data. Because as you can imagine, it gets quite complex to constantly call and get input data. The thing with GCS Fuse is you immediately start to access data, so it gives them some performance acceleration as well. Finally, the last part of the presentation is about parallel file systems. I think this is another area which is really gaining a lot of steam as AI/ML picks up. Parallel file system was commonly associated with Lustre. Lustre is a very popular parallel file system on-prem, and many cloud providers have managed Lustre solutions. But what we did at GCP is we launched something called Parallel Store. The reason we chose Parallel Store is we were able to achieve pretty high performance, basically 6.3x greater throughput performance compared to other alternatives. We published a paper on this with Intel DAOs. That's the technology we use underneath the hood for the parallel file system. So this is getting super popular now because, as you can imagine, a lot of customers want high throughput, low latency access to data. The nice thing about GCS Fuse is, you have the portability, but you have the throughput, but you don't have the latency. But with Parallel Store, you have both. You have throughput and latency. So that's something which customers can get out of the box with parallel file systems. And there's some of the use cases with Horoword and TensorFlow. We were able to achieve some really, really high, acceleration of data. And what is really interesting now, at least to me, in the data space and the AI/ML space is loading data is critical to making these training models run fast and these inference models running fast. You saw a Codeways use case. They are really, really interested in all of this. So what we're seeing is storage is becoming really top of mind again. I started this half of the presentation saying storage is more of a commodity. But now it's actually becoming more and more relevant, and it's becoming top of mind for users because it is a key bottleneck in shoveling your data to your accelerators to deliver the price perf you need for your end users. So that the last part is I just have a few deep dives. I just want to just FYI for you. We are constantly at Google publishing best practices of data and Kubernetes, be it Redis, Postgres, Kafka, MySQL. So we have a lot of guides out there. We recently published a few more guides using Kafka with Streamz, Kafka with Confluent. So it's all there as public documentation. Just FYI, if you want to kick the tires. And yeah, that's pretty much all I had. Thanks thank you for attending the session.